Hey everybody, this is Mr. Lamping. We're taking a look at section J-2 in our area unit. We're going to look at trapezoids, rhombuses, and kites today, and we're going to look at the areas of them. Got two more formulas for you to put in your list of formulas. The first one is the area of a trapezoid. Remember, the trapezoid looks like this with two bases that are parallel to each other and then two legs that are not parallel to each other. How do you find the area of something like that? Well, this is a sophisticated formula that will do it for us. The area equals 1/2 times the height times the sum of the two bases. Now remember, the height of a trapezoid is perpendicular to the base. So the height and the bases are always perpendicular. So let's look at why this works and why this formula works. So what I've done is I've actually cut out two trapezoids that are basically congruent. I just cut out two copies of the exact same trapezoid. I basically set the card on top of each other and I cut them out. So there they are, two of them. Let me zoom this camera out just a little bit so you can see a little bit better. I'm going to take these two trapezoids. I'm going to take one of them and flip it upside down. All right. Before I do that, let me go back this way. Let's identify some things in them. First of all, I went to the edge, so this length is 5 inches long. So this is 5 inches long. I'm going to call that base 1. This up here, I actually didn't measure it. I just simply cut it. Let me measure it, see if I can find a decent measure for it. It's about 1 1/4 inches. So not that it really matters. We're not going to really care, but we're going to call that base 2, 1.25 inches. Base 2, 1.25 inches. And then the height, which is perpendicular, which comes from this corner straight on down, perpendicular, remember, is 3 inches. And that's the height. And that's the height of this one as well. I'm not going to write it there. Okay, so now if I take this and I flip this upside down and I connect it, I have actually created a pretty large parallelogram. And so the area of this parallelogram, according to the formula we learned last time, is the length of the base times the height. So the length of the base here, here's base 1, which is 5 inches long, and this piece, it's upside down, but it says base 2, which is 1.25 inches long. So this base is 6.25 inches long. And that's where in the formula we have the base 1 plus base 2 part. That's this. That's this length. All right? And then we multiply it by the height, which is here, and that's the h part. So we're looking at b1 plus b2 times h, and then we simply take away half of the parallelogram, and that's where the 1/2 comes from. So the area of this piece would simply be this length plus this length, because that was what we had over here, times this length, and then 1/2 of that. So that's how that formula is found. All right, so that's the area of a trapezoid. And now if we look at the area of a rhombus or a kite, they're very similar. A rhombus has 4 sides that are the same length, but look at the diagonals. We've talked before about the diagonals in both cases are perpendicular to each other. Okay, so that's key here. So we're going to use this formula, area equals 1/2 diagonal 1 times diagonal 2. And here's how it works. Again, I'm going to use an index card. This is based, and I'm not going to need to cut this one off, because basically we have a kite, or this could be a rhombus, and we have a perpendicular height and a perpendicular base. That's 5 times 3. So the area of this index card, again, is 15 square inches. But you can kind of see that we're going to cut off this part of that rectangle there. We're going to cut that piece off. We're going to cut this piece off and throw it away. We're going to cut this piece off and throw it away. And we're going to cut this piece off and throw it away. So how much of the card are we cutting off? Half of the card, because these two are the same, these two are the same, those two are the same, and those two are the same. So we're basically cutting away half of the card, throwing it away, and leaving this kite inside here. So our formula turns out to be 1/2 this diagonal times that diagonal. And those are the formulas you're going to want to have on your list for when you have an assessment coming up here. Okay? And there's our notes for section J2.